Hey guys, this is elimination part 2. I know this is a very long lesson, but it's very important, and I hope you guys are working every single problem with me. All right, so now the first types of problems we did, something eliminated each other, another variable simply by the way the equation was written. And then we looked at multiplying numbers by -1 or equations by -1, and then numbers other than -1. Right. So now we're looking at just 4 problems that you can't just multiply one equation by a number, because look at this first example. We can't multiply -3 by a whole number to make it equal to 8. And the same thing is true with 4 and 5. So we're going to have to multiply both equations by a different number, okay? So our choices, so let's talk about our choices first. Let's say I want to eliminate my x's. Well, I'm going to think of the least common multiple of 3 and 8. Well, the answer is 24. So if this first x was equal to -24x and the second was equal to +24x, that means our x's would eliminate each other, right? So that's a choice. Let's look at our second choice. Let's look at -4 and 5. Well, the least common multiple of these two numbers is 20, right? So I can make both of these equal to 20, -20y and +20y. And to do that, I would have to multiply both equations by a different number. So I'm just going to go with the x's. I'm just going to go with eliminating the x's. So I do like that they already are different signs. So the least common multiple of 3 and 8 is 24. So to make the top x value 24, I have to multiply the whole equation by 8. Okay, so 8 times -3 is -24. The only thing to cancel out a -24 is a +24. So what do I multiply 8x by to make it equal to +24? The answer is 3. So now don't forget, you're multiplying every single number by whatever that, this one. So 8 times -3x is -24x. 8 times -4y is -32y, and 8 times -10 is -80. So there's our first one. Our second equation, 8 times 3 is +24x. 3 times 5y is +15y, and 3 times -13 is -39. All right, so what happened? Well, it gives us a way to eliminate our x's. Those are gone now, right? So now, what is -32? -32 plus 15y is -17y equals -80 minus 39 is -119. And now to solve for y, I'm going to divide both sides by -17. And my final answer is y is 7. All right, so y is 7. So here's my ordered pair. I don't know my x, but I know my y is 7. So, well, I'm going to have to write that back. So y is 7. So y is 7. So now I'm going to solve for x. So I'm going to go back to one of my original equations, not the one I changed them to, but that would also work. It doesn't matter. So I'm going to solve for x. So -3x minus 4 times 7 is -28 equals -10. So I would add 28. So I have -3x is equal to +18. And when I divide by -3, I get -6. So now I'm taking the second equation. I am checking my answer. So 8 times -6 is -48. Plus 5 times 7 is 35 equals -13. And that is correct. So I know that answer right there is right. I know it's right because I just checked it. So -6, 7 is my final answer. Let's try another one. All right, once again, I'm looking for opposite signs. I like my x's, they have opposite signs. My y's do not have opposite signs. Of course, I could always multiply by a negative number to make 1 equal a positive. But I like 3 and 4 because I know the least common multiple is 12. Since they're already opposite signs, I'm going to let my first x equal negative 12. So negative 3 times what is negative 12? The answer is 4. And then I want the bottom one to equal positive 12. So what times 4x is 12x? So that would be 3. So I'm going to bring this down. 4 times negative 3x is negative 12x. 4 times negative 6 is negative 24y. And 4 times negative 12 is negative 48. And then by 3, everything by 3. Positive 12x, look, that's what I wanted. I get to eliminate those x's. 3 times negative 10 is negative 30y. And 3 times 16 is something I should know. 16 times 3 is positive 48. My x's are gone. I have negative, 54y equals 0. 0 divided by anything is 0. So y is 0. So my ordered pair, y is 0. And then for x's, I'm going to bring down this stuff right here. The first one, I'll just do the first one. Get rid of some of this, it doesn't matter. All right, so my first equation, I'm going to plug in 0 for y. So negative 3x and negative 6 times 0 is 0. Equals negative 12. When I divide by negative 3, I get x is 4. So now, what if x is 4? I get 16 minus 0 is 16. That is true. So I know my answer is correct. All right, you guys try the next two. Try them and then come back and check your answers. All right, now this one, I don't have opposite signs in my x's or my y's, which is fine. I can make one equal a negative by multiplying by a negative. All right, so now let's look at our x's. Well, I know that 7 and 4 both have, the least common multiple is 28, and the least common multiple of 6 and 7 is 42. I'm always going to choose the smaller number, so I'm thinking about 28 is what I want both of them to be. One a positive and one a negative, right? So how do I make 7 positive 28? And how do I make 4 negative 28? Well, the answer is I multiply 7x by 4 to make it positive 28, and 4x by negative 7 to make it negative 28. Or, guys, I could have done the opposite. I could have made the top number negative 4 and the bottom number positive 7. It doesn't matter as long as one of them changes signs. So we'll just leave it in this form right here. All right, so we're going to multiply everything on the top by negative 4. So we have negative 28x minus, 6 times negative 4 is negative 24. Y, and then negative 12. And the bottom I have positive, that's supposed to be a positive. Let's just get rid of that mess. Go away. All right, so 7 times 4x is positive 28x plus 49y equals, what's 16 times 7? 112. So my x's are gone. I have 49y minus 24y, and I get 25y equals 100. And when I divide by 25, I get y equals 4. So now I'm going to plug 4 for y into this top equation right here. So I'm going to do 7x plus 6 times 4 is 24 equals 3. I'm going to subtract 24, so I get 7x equals negative 21. And when I divide by 7, I get x is negative 3 and y is 4. And when I think about this one, I get negative 12 plus 28. Is that 16? It is. So I know my answer is right. All right, one more of these. What about this one? Well, I'm not, these numbers are too big. I don't like them, but I like a positive 3 and negative 2. What's the least common multiple of 3 and 2? 6, right? So that's what I'm thinking in my brain. How do I make 3y equal 6y and negative 2y equal negative 6y, since it's already a negative? Well, we're going to multiply the top by 2 and the bottom by 3. So 2 times 10x is 20x. 2 times 3y is 6y. And 2 times negative 27 is negative 54. So then I have 27x minus 6y, and that would be 54. Yep. So this would be 47x, my y's are gone, equals 0, and anything divided by 0 divided by a number is 0. So my x value is 0. And now to get y, I'm going to plug in 0 right here. 0 times 9 is 0. So 0 minus 2y is minus 2y equals 18. Divided by negative 2, and I get y equals negative 9. So now I'm going to plug my answers into my original top equation just to check it. So if I plug in 0 here, 10 times 0 is 0. 3 times negative 9 is negative 27. So does negative 27 equal negative 27? Yes, it does. My answer is right. Okay. So that's how you do, that's probably the most complicated form of elimination, when you have to multiply both equations by a different number, but it's very doable, very doable. All right, so now we're going to look at some word problems. So my introduction, my very first video of systems of equations was a Farmer Brown question. Farmer Brown had this many animals and they had this many legs, and we had to write an equation for both of those scenarios. Well, that's what's going to be going on in these word problems. When you have two different criteria to meet, you have to write more than one equation. So we have two different things going on. We have prices of tickets, and we have number of people that went to the fair. Okay, we have a total amount of money that was collected and a total number of people that went to the fair. So that's what both equations is going to deal with. One's money and the other one's people. So a school fair ticket costs $8 for adults and $1 per child. On a certain day, the number of adults and children who went to the fair was 30. So the number of adults plus the number of children equals 30. There's our first equation. There were 30 people, and of those people, some were adults and some were children, right? Now, the other equation deals with how much money was collected. We had a total of $100. Well, however many adult tickets were sold, they were $8 a piece. So even though right now we don't know how many adult tickets were sold, we know that there was $8 times the number of tickets plus $1 per the number of children's tickets. So 1 times C, I could just write C, or I'm going to write 1C. It doesn't matter. So now I have, this is my system of equations. So there's different ways I could solve this. If I had a graph, I could graph it, which might be hard if I'm trying to graph a 100. But the other way I could do it is elimination. I could solve the top equation for either A or C and plug it into the other equation. Or I could choose elimination. So since we've been practicing elimination, that's what I'm going to do. Since my C's match, I know I can eliminate my C's if one of them is a negative C, right? So I am going to multiply this whole equation at the top by -1 so that I can eliminate my C's. All right, so I'm going to bring that first equation down. I'm going to multiply every single term by -1. So -1 times A is -1A. -1 times C is -1C. And -1 times 30 is -30. So 8A minus 1A is 7A. My C's are gone. And 100 minus 30 is 70. So when I divide by 7, I get that there were 10 adult tickets. 10 adult tickets. So of these 30 tickets, if 10 of them were adult tickets, that means 20 of them had to be children's tickets. 20. Because doesn't 10 plus 20 equal 30 tickets? And if adult tickets are $8 each, 8 times 10 is $80 of adult tickets. Children's tickets are $1 each, and there were 20 of them. And isn't $80 plus $20 $100? Yep. So I know this is the right answer. 10 adult tickets and 20 kid tickets. All right. Let's look at Jake and Seth. Jake and Seth put some money into their money boxes every week. The amount of money, which is Y, the amount of money they had after a certain amount of time, so X is equal to time, is shown. So we didn't even have to write our own system of equations. We just have to look at what they have come up with. After about how many weeks will Jake and Seth have the same amount of money in their money boxes, and what will that amount be? So remember, X represents time and Y represents money. I guess we could put total money. Okay, so they're asking both questions. How much time will it take and how much money will they have? All right, so since both of these are already set equal to Y, I'm going to solve this. I could do elimination. I could make that top 5X equal to negative 20X, right? Or since they're both set equal to Y, that means I'm going to set these two equations equal to each other. If they're both equal to Y, that means 5X plus 85 is equal to 20X plus 40. Now I'm going to get those X's together. I'm going to subtract 20X. Oh, I should subtract 5X. Let me back up. I'd rather subtract 5X from both sides. No, I thought I used my eraser. All right, here we go. All right, I'm going to eliminate my 5X by subtracting 5X from both sides. So I have 85 equals 15X plus 40. And now I'm going to subtract 40 from both sides. And I get 45 equals 15X. I'm going to divide both sides by 15. So X is equal to 3. And what is X? X is time. So these are weeks, time in weeks. So it takes 3 weeks for them to get the same amount of money. So how much money? That means now we have to solve for Y. So let me erase all this stuff. So, whoops, I don't want to erase my answer. Half of my answer is 3 weeks. And then I'm going to plug in 3 for X and figure out what Y is. So Y is equal to 3 times 5 is 15 plus 85. So what is 15 plus 85? It's $100. Remember that was their money? So they each will have $100 after 3 weeks. Let's make sure that's true right here too. After 3 weeks, 20 times 3 is 60. And is it 60 plus 40, 100? So that's why the answers are the same for both guys, because we solved our system of equation correctly. All right, here's a good one too. Once again, they've already written the equations for us. It says the distance in the distance is in miles. So Y equals the distance in miles of 2 cars from their starting points at certain times in hours. So X is time in hours are shown by these equations. After how many hours will the 2 cars be the same distance from their starting point, and what will that distance be? Okay, so they're starting at the same place and they're going different speeds, right? They're going different speeds, and I guess they didn't start at the same place. This guy started at 10, mile marker 10, I guess, and this guy started at mile marker 70, We want to know how far they will both be at the same distance from their starting place. So basically, once again, we have two equations that equal y. And anytime I see an equation, two equations that are equal to the same variable, I'm just simply going to make those two equations equal to each other. So here we go. So once again, we're going to solve for x. We're going to get our x's together. So we have 20x plus 10 equals 70. I'm going to subtract 10 from both sides. So I have 20x equals 60. And when I divide by 20, I have the hours 3 hours. So in 3 hours, what will this distance be? 3 hours, what will the distance be? Well, if x is hours, let's plug in 3 right here. What's 40 times 3? That'd be 120, and 120 plus 70 is y equals 190. 190 miles. That's what y is, distance in miles. Let's make sure it's correct for car A. So 60 times 3 is 180, and 180 plus 10 is also 190, which makes us know that our answer over here is correct. Mike and his friends bought cheese wafers for $2 per packet and chocolate wafers for $1 per packet. They spent, so two different things going on, how much money they spent and how many packets of wafers they bought. So one of our equations has to do with the number of wafers. The other one has to do with money. Okay, so of the 20 packets of wafers, some of them were chocolate wafers and also cheese well, we can't use C. So we'll say X for cheese wafers, Y for chocolate wafers. How about that? Can't use two C's to represent two different things, can we? All right, let's get rid of this. So of the total wafers that were used, they were cheese and chocolate wafers, and we had a total of 20. Easy peasy, right? Now we're dealing with money. So how much were the cheese wafers? They were $2 each. So however many packets we bought, we spent $2 times the number we bought plus $1 times the number of chocolate wafers. So 1 times Y is Y. And they spent a total of $25. So how are we going to solve for this? Well, since our X's and Y's are lined up on each other, I'm going to use elimination. I'm just going to multiply everything in the top equation by -1. So X times -1 is -1X. Negative Y equals -20. So 2X minus 1X is 1X. The Y's eliminate. And I have 5. So X is half of my answer. So I'm sorry, 5. So we have 5 cheese wafers. 5 cheese wafers. And if we spend a total of 20, that means we'd have to have 15 chocolate wafers. 15 chocolate wafers. All right, so let's double check. Does 5 wafers plus 15 wafers give us a total of 20 wafers? Yes. If we spent $25, well, 5 times 2, these are $2 a piece. 5 times 2 is $10 for cheese wafers. The chocolate wafers are $1 each, so 15 times 1 is 15. And does $10 plus $15 equal our total of $25? Yes. So this is the right answer, and I am sure of my answer because I checked my work. All right, you guys, well, that's it. So I hope that helps you guys. I hope you guys work hard on this. This is a great and a very important standard for 8th grade. And next week is your practice test, our test review, and your unit test, your last one. All right, let me know if you guys need any help from me. I will see you guys later.